Hey there, Sevens. So I looked at the work everyone submitted this morning, and there's some awesome, really interesting differences in the way people described and did things. I really like this description this student had. This will totally work, but you'll realize when we look at some other students that it's slightly overly complicated. So this person said, we count how many trees are in one row and how many trees are in one row in length. Sorry, so like across the top row here and across the side row here. Um, and then multiply those two numbers, so you're finding like how big the entire thing is. And you count how many spaces. So she's saying like you include all of the spaces. You subtract that number from the multiplication because those are spaces, so you have to subtract them out. And then you count the number of young trees and subtract it for old trees. So basically, this person is saying you can use the top row here and the left column here, I think, as a representative sample of the entire space. So you use what's in those pieces and kind of like blow it up or multiply it up to make the entire space. Okay, that makes sense to me. But we don't actually need to do these subtractions. This is another way, it's a bit more simplified, but same idea. If Tom draws a 10 by 10 square around some trees and counts how many old and new there are, then there are 50 rows and 50 columns, so we need to multiply by 25. This is actually a really efficient method, but it's hard to follow. So another student had included a diagram, and this diagram makes it so much easier. So let's look. A 10 by 10 square around some trees. Good, I see a 10 by 10 square here, and if you count it out, it's 10 by 10. And you count how many old and new trees there are in that 10 by 10 area. Then you need to multiply by 25. I can see that down here because I've got 5 rows and 5 columns. Or sorry, I should say 5 columns this way and 5 rows this way. But so there are 25 total boxes that you need to multiply by to blow up and get the whole population. I like that. It could be a lot clearer if this person had included this type of diagram or made it clear that like 10 times 5 is 50, and that's why this is like times 5 and times 5 makes an array of 25. But it's going from a 10 by 10 to a 50 by 50. This is not an obvious jump. This last person had a really good description. I like this a lot because they didn't get caught in specifically 10 by 10 and 50 by 50 and whatever. They in general said, at first, you divide the trees into small equal areas. Then you need to calculate how many trees of each type are in each area. And then you need to find how many trees are in all the small areas total by multiplying. Interesting, I didn't realize it feels like it gets off when they say how many trees are in each area. Well, you don't need to count each area or you're counting all of them. But they get at the idea down here that you really just need to multiply and like get one area or maybe a couple areas to make sure that it is representative. She divided into 5 total equal areas, which is just like this person did and just like the person in the upper right. So you guys have the idea. What we're going to add is some vocab to it. Here's some of the vocab we're going to look at. We'll have what we're talking about is a sample, which is where you guys made different choices. But the last 3 people all used a sample that was this section. So that would be the sample for the population. Come on. Population, which would be the entire thing, like this whole space. Come on. Sometimes I hate technology. The whole thing is the population, and that small area is the sample that you used. Okay, well that makes sense. You choose a small sample and multiply it out in order to represent an entire population. Great, so let's look at more. Let's get some definitions first. We're going to talk today about sampling and then about making inferences about a population. So definitions. A population is an entire group of people or objects under study. In this case, we were studying all of the trees in the tree farm. So the entire group is the population. The sample is a small set of the population. So in our case, we chose this sample up in this corner. But there's this additional problem that comes up often in statistics of random samples versus biased samples. A random sample is a small set of the population that represents the whole population in the way that differences are distributed. So it just means that whatever's variation happens in the population, it should also happen in the sample. That's all. So a biased sample is a small set of the population that has significant differences from the population. So let's look at some examples. In order to do that, we're going to play a little game called representative sample or biased. This should say random sample or biased, but I guess they're not all randomly chosen. That's why I said representative. But random samples are representative. So I'm going to ask, in our situations, are the samples representative or biased? Okay. So in this situation, I want to know if the sevens want to go ice skating. Maybe that's a possibility. I want to know if we want to go ice skating. So I just ask Mark. Whatever Mark tells me, that's going to be representative of everyone. Does Mark represent the entire 7th grade, or is this a biased sample? Well, Mark might represent the whole 7th grade. Like maybe he chooses the same thing that you guys would all choose together, but I'm not convinced. I would say it's a biased sample because maybe Mark doesn't represent you guys. So what if I want to know if the sevens want to go ice skating? So I just ask the girls. So the girls are the only ones I ask, and that's it. Well, this is again going to be a biased sample because the girls might not represent or might not respond the same way the boys would. I really need, like, the girls have differences that are not representative of the entire population. The same way Mark has differences that do not represent the entire population because Mark is only an individual. So how about if I wondered how many people in Riga had eaten tacos today? That's what I want. Or how many tacos people in Riga had eaten today. So I asked my Wi-Fi, my Venezuelan friend, and our 3 Mexican friends that live here in Riga. Well, it's obviously a biased sample, right? There aren't that many Latinos that are living here in Riga for me to ask these people about tacos. And they're probably more likely to eat tacos because they're from areas that have similar types of cuisine. So it is a biased sample because these people have differences that don't represent the Riga population. Another one, I want to know how many tacos were eaten today in Riga. So I stood outside a taco restaurant and I asked everybody who walked by from 8 a.m. to 8 p.m. So this is actually a better sample. We're getting closer now. It's getting closer because everybody who walked by, that's probably a lot of people. But again, it's biased because we're outside of a taco restaurant. I would say this is still biased, but we're beginning to move in that direction. Like this is a lot better because everybody who walks by on a street corner, well, that's a lot of people, and it probably does begin to approximate Riga. It's just that you're outside a taco restaurant, probably more people are eating tacos. What if you wanted to know how many tacos were eaten today in Riga? So you went to Old Town and you just asked 3,000 people, any random 3,000 people that come by. Well, this is actually a really good question. Is this representative or is it biased? The only thing that makes it feel like maybe it's biased is that you didn't go all over Riga. These people aren't from different places. They're all in Old Town. So maybe there is a bias there, but maybe it's representative. You are choosing, in some sense, just the first 3,000 Rigans that you encounter. So that is like a good example of something that could say, like you could argue that this is representative. You could also argue this is biased because you're only in Old Town. I would probably be inclined to say that this would be a representative sample, but I could be wrong. And I'm just saying other people might argue both sides, but those would be reasons to argue both sides. So I have one example in American history when this super mattered. So in 1936, we had a presidential election, so President of the United States. The famous incumbent FDR is running. So Franklin Delano Roosevelt was the president for 16 years, longest running president in American history. And the governor of Kansas, Robert Langdon, was running against him. So we got FDR versus Robert Langdon. There are these prediction agencies in the US, and they decide who they think is going to win by making polls. So they published that Langdon would win with 57% of the vote to FDR's 43. That is a crushing political victory. That's like way more votes, winning by 14%. In the end, it went the other way. Franklin Delano Roosevelt actually won by 58% of the vote. So how could this agency have been so wrong? These people are smart. This is what they do for their living. Well, the reason is the survey was conducted by telephone, and in 1936, only the wealthy had telephones. So the sample was biased. You only asked wealthy people. The wealthy people were voting for Robert Langdon. This was a biased sample, and it created a lot of surprise and uncertainty in America in 1936. So good. Your guys' assignment for now. I just have these situations, a list of situations A through L, and I want to know some of these are biased and others are not. So which ones? Like separate them into biased samples versus random samples. So as an example, the nutrition department, like we don't have a nutrition department, but maybe Ilza. Ilza wants to know the school lunch preferences of everyone in the entire school from kindergarten to 12th grade in some school, Elk Grove. So they go and ask all the kindergartners, is that a biased sample or is that a random sample? That one is super obvious. If you're not sure, get a hold of me. If you are, go ahead, separate these out. Which ones are biased and which ones are random? Best of luck. Go for it.